Okay, in this video what I want to do is talk about the GCF. The first thing we should try to do is take the GCF, or find the GCF, and then take it out if there is one. So I'm looking at this one, my example I wrote here, 2x squared plus 6x plus 4. I actually have a second one over here. We're going to do it 2 times in 2 different ways. But I should see at this point that I have a 2 as greatest common factor. 2 goes into all 3 of these numbers. So what I'm going to do is take that 2 out. 2 is my greatest common factor, which leaves me x squared plus 3x plus 2. So what I need to do at this point is factor that quadratic. This is a fairly simple one to factor. I try to make it as simple as possible to show us this differences. We totally ignore this 2 for now. I'm going to take my x squared and put it here. My 2 goes there. Multiply my c times my a, and I get 2. Let's go ahead and factor that 2. Should be wonderfully easy. 1 and 2. That's it. They should add up to 3. Of course, only 2 factors, they add up to 3. So 1x and 2x. Inside this box is probably one of the best places to go ahead and put a 1 if the leading coefficient's a 1, even if it's not what we normally would do. To me, it just makes things a little bit more obvious inside of the box. The greatest common factor here, we have x times x squared, x times 1 is 1x, this needs to be 2, that means 2 times 2 is 2. So those are my 2 different factors. We end up with x plus 1 times x plus 2, and the only thing we need to do at the end is go ahead and add this 2 at the beginning. So when we have this greatest common factor, we end up with 1, 2, 3 different factors. Now what I want to do is compare that to doing this same exact problem, but I'm going to pretend I forgot to check and see if there's a greatest common factor and see what happens. There's 2 different things I want to point out while we're doing this. I'm going to go ahead, since I'm ignoring the greatest common factor, we're going to go straight into the box. Okay, let's see what happens. My 2x squared goes here, my 4 goes right here in the bottom right box. Now, when I multiply c times a here, I get 8. When I'm factoring now, instead of factoring the 2 like I did originally, I have to factor 8. Start with 1. 1 times 8 is 8. 2 is a factor. 2 times 4. 3 doesn't work. 4, we've started repeating. So let's go ahead. We are going to try to match 6. So somewhere here, I need to match b in this case, which is 6. So add those up. 1 plus 8 is 9. That doesn't match. 2 plus 4 is 6. Hey, there's the one I'm looking for. In these 2 boxes, I need 2x and 4x. Now, I'm going to double this one up. I'm going to rewrite this box down here on the bottom and show us why I do the GCF only once. 2x squared, 4x, 4. Okay. If I was to do the GCF both directions in all 4 of these, this would be 2x. Both have a 2, both have an x. If I go this way, I will again get a 2x. And then here I will have a 2, and here I will have a 4. So that's GCF here, GCF here, GCF here, GCF that way, GCF that way. Problem is, because we didn't take the greatest common factor out, this no longer works. 2x times 2x is 4x squared. It doesn't match up. Obviously at the end it's not going to match up either. 4 times 2 is 8. That's not right. It only works if we have to take the GCF out. So what I tell everyone to do, what I suggest we do greatest common factor, the one single time. They both have a 2. They both have an x. Then we piece together the rest without using the GCF. We have 2x times x would be my 2x squared. This needs to simply be a 1, and this needs to be a 4. Again, I checked this last one, and I end up with 4 right there. Perfect. I'm also going to draw a second one on the bottom that's going to be a mirror of this. And let's just say we rewrote this, and here's my box, and we put 2x squared here, 4 here, and put 2x there and 4x here. What I've done is switch these two. If I do that and I do my greatest common factor here, I get 2x here, this is going to be x, this is going to be 2, and this is going to be 2 as well. 2 times 2 is 4. Now the reason I did this one, we know why this one is wrong. Watch what happens when we pull these factors off. This is x plus 1 and 2x plus 4. This third one I've done, my factors are different. X plus 2, and then we have 2x plus 2. The reason I am showing all of these is you could get partially different answers. Let me go ahead and kind of reset this. It's starting to get a little messy. X plus 1, 2x plus 4, right there. And what's the next one? X plus 2, 2x plus 2. Now we know the answer. And over here in the blue you see the answer. What you might notice is there's an x plus 1 on this one, but the x plus 2 is missing. This one has the x plus 2, but not the x plus 1. So it seems like they're partially correct. What they're missing is this greatest common factor. And what I'm going to do for this first one is I'm going to rewrite it. I'm going to switch these, because this one, this first binomial, it's as simple as it can go. But if I look at the second one, hey, there's a greatest common factor in that one. So I'm going to make it like this. You don't have to switch the order. I just like switching the order like this because it helps with the next step. There's a greatest common factor of 2 in this first one. So I'm going to take that 2 out. I'm going to say 2x plus 2, because that 2 times x is 2x, 2 times 2 is 4, and I do not touch this one. Now, they match. They're switched, the orders are switched slightly, but they're the same. Then for this one, I look, oh, there's a greatest common factor on this one. I see that they both have a 2. I'm going to switch those again just because it makes it a little bit easier to show it to you. And as I look at it, I see there's a 2, 2 times x is 2x, 2 times 1 is 2, and then x plus 2. Now we have another match. So whether we end up taking the GCF at the beginning, or we forget and then take the GCF at the end. If your test has multiple choice questions, hey, it's not that big of a deal. You won't see a matching answer. You know to look for the GCF. Again, I would try to do this because the numbers become larger. This was very, very, very simple. Only one set of factors, plug everything in. There's not a lot of thinking involved in this. This one, our numbers get bigger. If you don't take the GCF out, these numbers can get very large. You might have a factor tree that's this long before you find the right b value. Then there's 2 different ways you could do it. Again, this third way, we don't do this. That's why we only do greatest common factor 1 time. Then once you take those out, just check for the GCF at the end to make sure. What I like about this method is this may be more difficult, but finding that GCF here is a lot simpler. checking 3 numbers to me is harder than checking 2 here or 2 here. But either way, you should get the right answer unless you do it this way, which we don't do.